Welcome to The Explainer. Today we're exploring an absolutely massive transformation happening right now in software engineering. We're looking at how OpenAI Codex has evolved from just, a simple autocomplete tool guessing your next line of code into a fully autonomous digital colleague, one that you can safely scale and actually govern across an entire enterprise engineering team. So whether you write code, manage developers, or oversee tech infrastructure, you're definitely going to want to pay close attention to the shift.
Here's our roadmap for today. We'll kick things off with the agentic coding era, then look at automating legacy code migration, building the elements of perfect prompts, systematizing with agents.md, exploring advanced workflows and skills, and finally, governing AI at scale. Let's start with a really crucial question for everyone watching. Are you still using AI as just an autocomplete tool? Because if you're just tabbing to complete individual lines of code in your editor, you are missing out on a massive paradigm shift. We aren't just speeding up typing anymore. We are actively delegating complex, multi-step engineering tasks to digital teammates.
Which brings us to Section 1, the agentic coding era, moving from suggestions to autonomous workflows.
Now, looking at the 2026 landscape, we've got two heavyweights that might look similar on the surface, but operate very differently. On one hand, the GitHub Copilot app acts as an async collaborator. It can read issues, open PRs, and crucially, it lets you choose your AI provider, like Anthropic's Claude or Google's Gemini. On the flip side, the OpenAI Codex CLI is a terminal-based agent, giving you incredibly deep, sandbox-level integration right in your local environment. But it's strictly locked into the OpenAI ecosystem, defaulting to their O3 or GPT 5.5 models. The choice you make here literally dictates your entire workflow.
All right, Section 2. Automating legacy code migration, putting the digital colleague to the test.
Take a look at this number, 2.5 million. Researchers recently took on a massive legacy system at a Dutch financial institution, containing 2.5 million lines of completely undocumented PLSQL code. Honestly, a developer's worst nightmare, right? Doing that manually would take years and an absolute fortune. But by leveraging large language models, they successfully began translating this ancient architecture into modern Java. This really proves the sheer scale of what our digital colleagues can now handle.
Now, you might think feeding the AI every single example of old code would yield the best results. Well, the data shows the exact opposite. By using a technique called cosine similarity to feed the AI only a curated, highly similar subset of code, researchers dramatically increase the success rate, specifically the rate of test cases passed. So it turns out that precision and relevance in your prompt are way more important than just dumping massive amounts of context into the model's brain.
Moving right along to Section 3, Elements of Perfect Prompts, setting the definition of done.
The official Codex guide outlines 4 non-negotiable steps for your prompts. First up, the goal. What's the exact outcome you want? Second, context. Which specific files and docs does it need to read? Third, constraints. This one is huge. If you don't explicitly tell it to use a specific UI framework or coding standard, it's going to guess, and it will often guess wrong. And fourth, done when. You absolutely must provide a definitive verification condition, like done when all tests pass, so the model knows exactly how to verify its own work before clocking out.
And the official documentation emphasizes a massive mindset shift here. You need to treat Codex as a teammate with whom you build up settings over time, not just a one-off assistant. We have to stop the bad habit of feeding it context from scratch every single time we open the terminal. I mean, you wouldn't re-explain your company's entire tech stack to a human engineer every single morning, right? So you definitely shouldn't do it to your AI either.
Which leads us to Section 4, Systematizing with agents.md, creating the employee handbook. Enter agents.md. Think of this as a persistent markdown file sitting right at the root of your repository. It essentially acts as a permanent context rulebook that loads automatically at the start of every single session. Because this file exists, you don't have to waste precious prompt space reminding the model to use TypeScript or a specific directory structure. The AI just knows.
So, what actually goes into this handbook? Well, you want to keep it short and highly accurate. Focus on core components like exact build, lint, and test commands, architectural conventions, and your PR expectations. But definitely pay special attention to that last point, forbidden actions. You have to explicitly tell the AI what not to do. For example, never edit database migrations or do not rewrite the tests just to make them pass. Setting these strict boundaries ensures your digital colleague doesn't accidentally break the build or, drop your production database.
And when you're dealing with vague or really complex tasks, you should heavily utilize Plan mode, which you can trigger with Shift+Tab. Instead of just jumping straight into writing code, Plan mode forces the AI to gather context, ask clarifying questions, and build an actual strategy. You can even have it conduct a reverse interview where it questions you about the requirements. Taking that time to plan really avoids compounding errors later down the line.
Okay, Section 5. Advanced Workflows and Skills. Optimizing performance and external tool usage. To extend your AI's capabilities, you've got two distinct tools, and it is vital to know when to use which. First, we have skills, defined in a skill.md file. These are repeatable workflows for specific jobs, like generating a standard UI component, and they only consume your context window when you specifically trigger them. On the other hand, the Model Context Protocol, or MCP, provides a direct, always-on connection to external tools or databases. But a quick warning, MCP is always actively sitting in the AI's memory, so it is constantly consuming context. Basically, use skills for routine tasks and MCP only when real-time external data is absolutely necessary.
You also need to manage how hard the AI thinks. When setting the reasoning effort, you want to use medium or high as your baseline for day-to-day coding. This gives you the absolute best cost-to-performance ratio. Low reasoning often leads to silly mistakes on complex tasks. Meanwhile, reserve that extra high setting strictly for long-duration, massive architectural tasks. Honestly, using extra high for a simple bug fix is just a massive waste of your context capacity and your budget.
Finally, Section 6. Governing AI at Scale. Corporate oversight for a fleet of digital developers.
This brings us to the Bifrost AI Gateway. Because when you scale Codex, you obviously can't have hundreds of developers making direct, unmonitored API calls. Bifrost is an open-source layer that seamlessly intercepts Codex CLI API calls. It sits right between the developer's terminal and the LLM provider, offering robust, centralized governance and essentially acting as the management layer for your digital workforce.
By routing traffic through this gateway, platform teams instantly gain incredible oversight. You can issue virtual keys per developer or team with strict hierarchical budgets. You get comprehensive SOC 2, GDPR, and HIPAA-compliant audit logs of every single line of code generated. You can securely store actual provider API keys in HashiCorp Vault so developers never even see them. And the absolute best part? It adds a virtually invisible 11 microseconds of latency. Your developers won't even know it's there.
And this provides the ultimate flexibility for enterprise teams. Remember earlier when we noted that Codex CLI is locked to OpenAI? Well, the Bifrost Gateway actually breaks that single provider lock-in. It translates the requests, enabling you to seamlessly route your Codex CLI to Anthropic's Claude, Google's Gemini, or even self-hosted air-gapped models. So you get the deep terminal integration of Codex with the model freedom of Copilot, all without changing the developer's workflow whatsoever. The era of agentic coding is fully here. But as these autonomous AI teammates become standard, the question isn't really whether you'll use them, but how will your organization properly govern this incoming fleet of digital developers? It's definitely time to start building your AI employee handbook and gateway infrastructure today. Thanks for joining me for this explainer, and I'll catch you on the next one.